Hey everyone, welcome to my channel. So today we are going to discuss about Leetcode problem fruit into baskets. Fruit into baskets. So the problem description says we have a row of trees and the ith tree produces fruit with type of tree I. So let's say we have a row and then we have all trees in this row, and one tree, like let's say ith tree, it produces fruit of type tree of I. So this is a fruit of fruit type. And it also says that I can start at any I can start at any tree, like let's say I can start right here or maybe right here or here, anywhere. And when I'm moving to the right, when I started somewhere right here and then when I'm moving to the right, so at every tree I can actually put this tree into one of my baskets. So I have like two baskets, basket 1 and basket 2. So basket 1 and basket 2. So I can put tree into either of these baskets, either this or here or here. Or if I'm unable to put a fruit into my basket, then I'm gonna stop right there. And yeah, and we also stop when we reach the end of this row. So, and also like we don't have any choice after the initial choice of my starting tree. That means like if I start at some position I, and then I should either take a fruit at the I plus 1th position. Let's say this is I can either put this fruit into one of these baskets, or I should stop right here if I'm unable. That's it, I cannot skip this tree. One more condition they have mentioned right there is, so each of these baskets, they can have only one type of fruit. They can only carry one type of fruit. That means like there can't be like more than one unique type of fruit in each of these baskets. And one more thing is that each of these baskets, they can carry any quantity of fruit. And the question here is what is the total amount of fruit you can collect with this procedure. Total maximum amount of fruit you can collect with this procedure. Yeah, some of the fruits in basket 1 plus basket 2. So let's solve an example. So we have 1, 2 and 1. So we have two baskets, basket 1 and basket 2. Let's say we start at index 0. So this is index 0, 1 and 2. So we start at index 0. We have right now we have basket 1 and basket 2. So those two baskets right now initially are empty. So I started index 0. So I put this, let's say I can put it in basket 1. So we have now 1 here in this basket. And then in the next step I move to the next position, and then I go here and then I put this fruit into one of these baskets. Since there is already a type fruit of type 1 in basket 1, so I can't put that fruit in that basket. So what I do is I put this fruit into this basket, and we move to the right again, and then we have fruit of type 1, and I can put this into this basket. So answer would be like we have like 1, 1, and then we have 2 here. So total we can have like 3. Yeah, 3 basket. There are 3 fruits. Let's solve the another example in this question. So it is like 0, 1, 2 and 2. And we have 2 empty baskets in the beginning, basket 1 and basket 2. So let's say we started index 0, and then we have fruit of type 0. So we can put it any one of this basket. So we put it right in this basket, and then we move forward. So once we move forward, and then we have a fruit of type 1. So since we already have fruit of type 0 in basket 1, so we put that fruit in basket 2, and then we move forward, and then we have fruit of type 2. Now we don't have any basket which is either empty or a basket which contains a fruit of type 2. So either we need to remove either we need to remove all the fruits of type 0 from basket 1 and put 2 into that, or we should completely remove all the fruits from this basket 2 and then put into 2. But the problem here right now is we need to have a continuous segment. By that I mean, let's say we started right now at here, and then we are at this position. We started here, and then we are at this position. So I cannot remove 1 without removing 0, because if I remove 1, that means I have collected 0 and then I've skipped and then I've moved to 2. So that practically is impossible. Removing the fruit of type 0, I remove this, and then we move our starting pointer to here. So we move our starting pointer to here. So right now we have 1 and 2 in our baskets. So once we remove this, we put our 2 in here, and then we again move our right pointer. We move this here, and now E is at here. Since we already have a basket with which contains a fruit of type 2, so we add just 1 here. So the maximum possible would be 3. 2 plus 1, which is 3. We maintain 2 pointers, the left pointer and the right pointer. We keep moving the right pointer towards the end of right, and then if at some point if we are unable to insert a fruit into a basket, into one of these baskets, then we keep moving our left pointer towards right. That means when we are moving our left pointer towards right, we remove the type of that fruit from our basket, and then check if we are able to add which we were unable to add before. So the way I do that here is like, so I'll maintain a set here. And then I also have a map maybe, and then I have all the fruits. Let's consider this above example, which is like 0, 1, 2, 2. So it's 0, 1, 2 and 2. So we started 0. Yeah, we also have to maintain a variable answer which maintains the maximum possible so far. So we started index 0. We start here, and first thing we do is like we insert that into our set, and we also maintain the frequency of each of the fruit in the map. So we maintain the frequency of each fruit. So we maintain the frequency of each fruit, and by using this set, we kind of maintain the number of unique fruits so far. We started index 0, and then we put our set. We have put that into our set 0, and then answer for now would be 1, since we still don't have anything. And then we have our right pointer. Let me mark that right pointer with the red color. So we move our right pointer to 1 index right. So that means we are right now at 1. And we, at every step when we move our right pointer towards right, so what I do is I increment the value of map. So I increment the value of map of that fruit by 1. Since when there is a transition from 0 to 1 in our frequency map, that means a unique new element has been added into your basket. So in that case, I insert into the set. And after inserting into the set, I check the size of the set. If the size of the set is greater than 2, if at any point of time if it's greater than 2, that means we have like more than 2 unique fruits in our baskets. So right now we have only 2 unique fruits, so we are good for now. So we again move our the right pointer towards right. We move our right pointer towards right, so we move it right here. We are now at 2. So once we are at 2, we try to increment the value of frequency in the frequency map by 1. Since again this is a transition from 0 to 1, that means this is a new unique element. So we try to now insert this element into a set. Now the size of this set is 3, which is greater than 2. So by that it means we have like a 3 unique elements. So here we got to know that we have like more than 2 unique elements, so we keep on popping out all the elements from the left side. So we have this left pointer right here, and then we move this left pointer towards right, and we move from 0 to 1. So we move from 0 to 1. By moving our left pointer from 0 to 1, so we are decreasing the value of 0 by in the frequency map we also decrement the value of 0. So we decrement the value of this map value, and then this would be 0. So 1 to 0 means we have one less unique element in our set right now. So when there is a transition from 1 to 0, so we need to eliminate this value from our set, and then we check again if we have 2 unique elements. So right now we have only 2 unique elements, 1 and 2, so we are good. So we max this with our answer. Which is like now 2, and then we again move our right pointer towards right. So we move right pointer towards right. So again we have 2 now here. We increment the value of 2 in our frequency map by 1. So that would become 2 now. So 2, we are good now. So 2 is okay. And then because there is no we are not adding any unique element right here, or like you are removing anything, so it's fine. So we keep it this way, and then we again max it with our answer, so which is now would be 3. And then we don't have anything in the right side, so we stop our algorithm. So the maximum possible answer would be 3 right now. I hope this makes sense. So you can see the code in the description below. So that's it about fruits into baskets. Any comments or suggestions, please leave them below in the comments. I'll leave all relevant links in the description below. Until next time, see you.